Hi everyone. Let me start with my introduction. So, I'm Ankush Pandey, and I will be trying to teach you some DSA questions here for the GFG. And let's start with my basic introduction, where I did my college and all from. So, I did my graduation from Triple IT Allahabad in the year 2022, and after that, I was from EC background, and after that, I got placed into Trilogy Innovation, which is known as Coordination also formally. And then after working there for around a year and a half, decided to move on and I decided to join PhonePe. From then onwards, I've joined at PhonePe since the start of this year and I've been working here. And before this, I had an internship during the last semester of my college at Hotstar also. So I did get a good exposure of things. And one thing that I realized in all these and hiring processes is that the DSA is very important if you want to get hired for a good company here in India specifically. So that was pretty much about me, and you'll get to know more about me as I upload more videos and as I solve more problems to help you out. So yeah, that was pretty much. Now let's jump to the core of this video. That is, I will be trying to solve a DSA problem, and I'll try to explain it so that more people can understand and do better and gain better jobs and do good in life. So yeah, the problem statement that I've picked up for this uh, session is very famous problem known as the LCS problem also, which is the longest common subsequence. So let me just start. I have already solved this problem somewhere earlier when I was trying to get placed. So yeah, so let's start. So I have given the problem statement says we are given two strings s1 and s2. Let's call them s1 and s2 with lengths this. Return the length of the longest common subsequence. If there is no common subsequence, then return 0. Alright, we have to return the length of the common subsequence, and nahi hai to definitely it's going to be 0. And what is a common subsequence now? What is a subsequence now before common subsequence? Common means definitely it is going to be same in both the substrings. Longest subset means the largest in the length, and the subsequence word, they have explained that here. A subsequence is a sequence that can be derived from the given string by deleting some or no elements. Now this part, without changing the order of the remaining elements. So whatever element is going to be deleted, it can be deleted. It cannot be added. That is to be noted here. It can only be deleted, or it can be considered in the subsequence of a string. But the order of the characters should remain same. For example, if I have A, B, C, D, G, H here and A, this S2 string here, A is present in both these substrings, and if we remove the remaining characters, we get A, which is the longest common subsequence. Now let's break it down further. Let's consider this substring only. Let me go here. Yeah. So I've written down the same problem here again, and yeah. So let's find out what is a subsequence first. So let's consider S1. We have A, B, C, D in S1. So subsequence of S1 would be the substrings or strings or a part of the S1 that we can create without altering the order of the characters of S1. So BCD, let's consider this BCD. Now in this BCD, what has been done? We have removed A, but the order of the remaining characters that are present, that we are using, is it same as it is in S1? Yeah, it is. So BCD is a subsequence of S1. Now comes ACD. In ACD, what we have done is we have removed B from this position. And is the order same for the remaining characters? Yeah, it is. So it's also a subsequence of S1. Then we have CD. Is it a subsequence? Yeah, it is a subsequence where we remove the initials A and B, and the remaining CD were kept. Now is D a subsequence? Yeah, definitely D is a subsequence where we remove the remaining characters. So this is how, and ABCD is also a subsequence of S1, and it is in fact the longest subsequence of S1 because it has all the characters and it has them in the correct order also as they are present in S1. So that's a subsequence. Now the question is we need to find the common subsequence. So these subsequences were for S1, but subsequences for S2, what will those be? Each single character will be a subsequence. Then let's go for 2. EC will be there, CA will be there, AD will be there. Then we have ECA also, we have EAD also, we have CAD also, we will have ED also. So you see, these all will be the subsequence of S2. Now the question is, we have to find the longest. So single character ones, we know D is there, D is there. So the smallest is pretty sure. Even if a single character matches, answer is 1. If it doesn't, answer is 0. There is no common subsequence, as there is no common character in these two strings. Now let's go to the two characters like CD. Do you find CD here? If you don't find, can you create a subsequence of S2 which has only CD, C, and then D? Yeah, it is possible, because we are maintaining the order and we are just removing certain characters while maintaining the order. So CD is definitely a subsequence of S2, and it is a subsequence of S1 also. So that means CD is a common subsequence. It is not the longest. We are not sure whether it is the longest or not. We'll have to find out. Can we find out a subsequence of 3 characters which is present in S1 as well as present in S2? Let's see. So the 3 characters would be, subsequence for 3 characters from S1 would be ABC. ABC would be there, ABD would be there, ABC, ABD, then B, CD is also an example. Is there any other example? ACD, ABD, is there? Yeah, these are the 3 characters. Now BCD is again repeated here again, so remove that from here. ECD is also removed there. For the 3 characters here, I think ECA, yeah, ECD is it covered? ECD is also covered. ECD, ECA, EAD is covered, done. Then we have CAD is there. So we have considered all the subsequences individually of S1 and S2 of 3 characters. Are there any subsequence which is common? I don't see any subsequence which is common. So that means the longest common subsequence were of 2 characters. It could be CD, or it could be CD, or it could be AD also. So the answer would be here 2. So this is the problem statement. So the way I would always like to approach a DSA problem is, first understand the problem. So here that part was understanding what is a subsequence. And then understanding what do we have to return as answer. It is the longest common subsequence. So there are 2 ways. Longest common subsequence. If I can find out all the common all the subsequences of S1, and find out all the subsequences of S2, and then we start comparing each subsequence of S1 with subsequence of S2 and see if they are same, the string should match now, because if they are same, we just find out the length of them, and the longest among them would be our answer. So that's the approach. Now this is what we do. We know, we have understood the problem, we know what we have to return as answer. And if we go for a brute force approach, that would be first step would be find out all the subsequence of S1 and store them somewhere. Similarly, find out all the subsequence of S2 and store this somewhere. And then what we'll do is compare all these subsequences of S1 and S2 and find the subsequence of max length. So if we can do this much, it's a very easy problem, and comparing wouldn't be a very complex thing. We just have to compare, that's very easy. But the problem would be finding out all the subsequences of S1 and S2. So what is a way to find all the subsequences of S1 and S2? So for that, let's go here and we'll try to, I'll just write a function, find subsequence. What it will do is, it will consider character where we have there, and it will string as well. For this, what we need is, we need to store these also somewhere. So what we'll do is, we'll create a set of string s1 subsequence. So what we'll do is I'll call this function from here, s1 subsequence would be equal to, it should be returning the set of string. Now this is what we are trying to do right now, is finding all the subsequence of each of these strings. Subsequence, find subsequence of all the strings. We'll start from 0 and we have stry. Similarly we'll do for str2 also, but for now let's consider this. Let's just comment this out. Yeah, so what does this I signify? So finding out all the subsequences, what we will do is, first of all, we'll keep on considering each characters. We are at A, we'll count it as a subsequence. So what we will do is, if E is there, what we'll do is, we'll keep a temporary string temp as empty, and S1 is there, we count S1, so we'll have to keep and pass this temp string also with us. The reason for that is, so this is empty right now. When we are starting, it should be empty also. But if I have reached the end of the string, at that point, what do I have to do? That point, I have to insert s1 underscore sb dot insert the temp. That means I have considered all the characters of s1. So this is just the corner case. Let's forget about this right now. So what you will be doing here, let's consider that. What I will be doing is, I will iterate through this string a, b, c, d, g, h. Let's consider a smaller example maybe. So custom input. Let's consider, okay, I'll have to, cool. Let's consider this only a, b, c, d, g, h. Let's consider this, yeah, a, b, c. So in this, what I'll do is, I'll try to find out all the subsequences of A. So what I'll do is, when I am at A, I'll consider that A into my temporary string. So what I'll do is, temp is equals to temp, whatever temp I have till now, I'll add that character. I'll add the current character into it. And then what I'll do, I'll say, now go ahead and find the remaining characters. Right? So what I did is, I started with A, ABC, I started with A, it went onward. I started with A, I added A into temp, which was empty earlier. I have temp as A, I stored it here, then I move forward. When I move forward, I have increased I to B. So now my temp is A and I am at B. I'll add B also into this, so it's now AB, and my temp is now AB, and I have moved to C. Now I'll again go to here. Now I have moved at C and my temp is AB. I added C also there. Now when I come back, I've added C also there. Now this happens again, and I increases to 0, 1, 2, 3 position. That is, if I is double equal to s1 dot size, that is, I have completed the string. At that point, what do I have to do? Whatever is the temp, s1 dot sub dot insert the temp, whatever the temp is at that point. So right now it was ABC. I have inserted into the set where I'm storing all the subsequences of s1. Cool. I'll return this, and then I do this, and then I return. So it doesn't have to return a subset also, it just has to be a void. It wouldn't be returning anything. So I have done. So now consider ABC has been considered. Now I come back to this flow, and my I was at C. I've considered C also. So what I'll do is, I'll remove this character. C has been considered. We move forward. We come back to this. We see ABC is there. We add it to the subsequence. Okay. And what I do is, since C is considered, what I'll try to do is, let's consider this a case. A is considered and we are at B. There would be a substring where we won't want to consider B also. So at that point, I'll just remove this last character from the, so this would be a string new temp, which will be equal to str.substring str from which will be equal to the temp dot every substring str, and it will be from 0 till I minus 1. So what I'm trying to do here is, I've considered A, B, C when I was considering B. So what I do at that point is, I want to ignore B, and I want to keep my options open. Once I've included B, I want to include C also after A. So what I did is, I removed that B and then I added C after removing the B. So that's what I have done. So sn.f subtract from 0 to this. Now what I'll do is, I'll again call find subsequence of what I'll do now is I plus 1 and s1, and instead of this it will be new temp. So by this, what I'm trying to do is, ABC is there, I considered A, then I have B and then C. I considered A was there, and then I came back, I removed A, here removed is A, and then I added the 0 to I minus 1, the new temp is empty. Then I moved forward B, C with new empty string. I came here, I added B into it, and then added C also into it, then came back, added removed B, added C, move ahead, moved back. So this way, and then I'll return. What I'll do here is, for auto t in set and s1 dot sub cout t. Let's do this and see what is the output that we get. Okay, I have made some mistake, I guess, somewhere. Line number 24 is here, it should be this. So what I am doing right now is finding out all the subsequences only, nothing more. What it says in memory in solution, this no match for operator equals true. So what this will do is, it will create our characters of substring this. So this is essentially, we are trying to find out all the subsequences. But is this a good approach? What do you think? I don't think it's a good approach, because we have to find out the subsequence of all the characters. What I have done is, I've written down the function to find all the subsequence in order to save some time. I have written down the function to find all the subsequence of given string. So for starting, we are considering just the string 1 and trying to find out all its subsequences. So if I compile and run this, and for the custom input, I've taken S1 as ABC only. So if you see ABC, and we have gotten all the subsequences of ABC. A is there, AB is there, BC is there, BC is there. So once we have these subsequences, we can do the similar thing for S2 also, find all the subsequences of S2, and then find out which all substrings are common, which all these subsequences are common in both S1 and S2, and that will be our answer. But the problem here is, since we are comparing we are creating all the subsequences, the time complexity of this would be exponential, because for each character A, whether we have an option, let's consider how we are finding the subsequence, all the subsequences of ABC. For each character A, we can include this in a subsequence or not. So there are two possibilities of this. Then comes B. We can include this also in a subsequence or not. So there's a 2 possibility of this. Now again for C, there's a 2 possibility of these, whether include or not. So it will go to 2 to the power 3 times. That will be an exponential time complexity, and we don't want that. So in order to solve this problem, what we will try to do is, we'll try to figure out a way which is much more simpler than this exponential time complexity. So let's go to the problem statement, and the problem statement says A, B, C, D, G, F, A, E, F, D, H, R. So now think along this line, think along these lines. If I were to break down the problem, so this was finding out. Now the next step is try to find out if there is a way to break the problem into smaller problem. So this is what we will trying to do now. So now consider A, B, C, D, G, H, and these, let's consider A, B, C and AC only. So what we'll try to do is, we'll try to compare A. We'll start from the starting of both the strings, A for S1 and A for S2, and then move forward. And every time we come across a character that is present in both S1 and S2, then that means it's a part of common subsequence, right? So that is going to contribute to our answer. That is, when we will be finding the longest common subsequence, that A is going to be a part of it, the longest common subsequence. So, and why would it be a part? It would be a part because it is present in S1 as well as present in S2 also. So at that point, we will be incrementing our answer by 1. That is, we have gotten a character that is going to be a part of longest common subsequence. And what do we do next? The next thing that we will do is, since A is removed, now it has been considered, so A is removed, we'll go forward. In S1 we are left with BC, and in S2 we are just left with C. So we'll start comparing the next characters of both the strings, B of S1 and C of S2. Are they equal? No. So what will happen at this point when we have BC and C? So at this point, what will happen? We are at B for this and we are at C. Are they equal? No. So what we will do is, we'll try to find out the cases where we now think along these lines. Now that this B is not the part of subsequence, because right now we have just compared this B with the first character. Let's consider this example as B, C, D, B. Now if you see here, right now we are at this B and we are at this C. Now as per this comparison, it's not a part of longest subsequence. It's not even a common character, because right now in our picture we just have this B and this C, and before this we had A. So this A was removed because we knew it's going to be a part, and now we have in picture just B. We forgot about A. We just have this B and C in picture. Are they common? No. But can they be a part of longest common subsequence? Think along this. Are they equal? No. So does that mean they cannot be part of the longest common sequence? Or if B and C are not equal, does that mean there is no character in B after C also? There is no character in S2 after C also. That won't be equal to B. Now that's wrong. There is a character in S2 which will be equal to B after C. So there is a possibility that B will match to some later on characters. So what we will do is, we'll try to consider this B which we had, and then we move ahead in the other substring. That, okay, it's fine, we didn't get a match right now, but we'll find and try to find a match in the later steps. So we remove C from here, and then the same thing goes here also. Currently C is not equal to B, but does that mean C is not going to be equal to any other character also in S1 which will come after B? No. So what we'll do is, we'll stick at C for the second string, C, D, B, and for the first string, since we know B is definitely not equal to this, we'll proceed on to the next character in this S1, that is C. So at this point this will be equal. So that means from here onwards we'll break it down into 0, and that is empty string, and C has been considered DB. But from this point onwards, this is the case where considered this. So this will be only this, because we know C is a part of subsequence. Now consider this example here, BCD. We have B. Now again B and D are being compared. Are they equal? No. So does that mean B cannot be equal to other characters also? No, it can be. So we'll keep on retaining B, and in the next character we'll remove the current character, which is in the next string we'll remove the current character. And similarly, if we go for this also, now this B and this D were being compared. Does that mean that D will not be equal to any other character in S1? We don't know of that, because right now picture me, we don't have those remaining characters. Our focus is just on the current characters and the characters which were before this, not after this. Or after this we'll have to go on and find out. So what we do is, for finding out further, we move forward. Okay, let me consider the next set of characters. Right now it's C, had it been C, X, Y, Z, we'll consider all of them also. So now C, and in the first case in the second string, we are considering the entire string is still present there. And we are comparing the D, because, so this is what I mean to say. Now, if you go on doing this, now you see there is a pattern in this. On the left, when we are moving, we are removing this thing and we are going to the next characters. And on the right, when we are moving, we are saying that, okay, we will not consider this character, we'll move to the next character in this S1, but S2 will remain same. So that's what we are doing essentially. And if I go here and show you this diagram, if I show you this diagram, okay, we can't paste it here. Let's paste it here. So you see, in this character, what they are doing is they are moving from the back. Instead of like we were moving from the start, they are moving from the back. So initially they are comparing T and X. Are T and X equal? No. So what they will do, on the left hand side, they'll say, okay, X can map to the remaining characters, but it won't map to any character after T, that is for sure, because we are moving from the back side here. So they said, okay, we'll consider the remaining characters which are after T, A, X, Y, and for S2 we'll just keep on comparing, because till now in S2 our focus is on X, but after that there are other characters also. So they consider this. When going to the right hand side, they say, okay, we are comparing now T to the X. Is T equal to X? No. But can T be equal to any other characters which are after X? Yeah, it can be. So we'll consider the entire S1 and we'll go A, Y, Z, and we'll remove X, because we know that T is not going to be equal to X. So this case is ignored. Then we move forward, we see that AXY is there. In the similar pattern, if we see, when we go to the right hand side, we say that the X is not equal to Y. So we'll remove X and we'll compare AXY with AYZ. We came here and we got this condition where we are going to compare two strings, AXY and AYZ. Similarly, from the right side, if we go on the left from this, we will see that T is not equal to Z. So we'll remove T and consider the entire S2. And you see this condition, AXY, AYZ, AXY, AYZ, it's same. That means that when we keep on breaking down the problem, we will be encountering the cases where we will be solving the same problem again and again. So is that a good thing? No, that's definitely not a good thing, because we know that although we have already solved it once, we are again solving it twice to find the answer. That's a overutilization of our resources. We are just consuming more time to find the answer that we already knew. So that is what we try to avoid while doing DP, by the use of DP, that is dynamic programming. We create for whatever cases we have the answer, we have encountered that case before, then we'll store that answer somewhere in a grid essentially. And then the next time that same situation occurs to us, we'll check in that grid, do we have that answer? And if we do have that answer, we'll just skip that. We won't break it down further. We'll just use that answer from their point itself. So since we will be proceeding in a forward fashion, let's consider I as 0 and J is 0. And then I have find LCS string. And then it will be I comma J. And then we have str1 and we have str2. And for right now, let's forget about this DP. Let's consider the case where we are just going to find this answer. So our answer would be, you would be returning this and it will be returning it. So what we'll do, we have AA. So first thing that we know for sure is if str1 of I is double equal to str2 of j, then that means we have got a character which is going to be the part of our answer. So what we'll do is, this one will be the value, will be the contribution of that character into our answer, and rest we'll find out more. I plus 1. Now because that character has been counted, we will go ahead and find the remaining character, search in the remaining characters in both the strings s2. I hope this makes sense because this is the crux of the entire question. I'll explain it again. What this means is, since A and A, the character which we are comparing right now, they are equal, then that means it is going to be a part of our answer. It is going to contribute to our answer. And what is it going to contribute? 1, because it's a single character which will be contributing, which will be a part of our longest subsequence. And right now, since we have to return the length, this A is contributing 1 length to that longest subsequence. So we have 1 here. And what if this doesn't happen? So if this doesn't happen, what we will do is we'll find LCS. First, we'll go to the left hand side. That is, will remain the left character. We'll see, okay, I'll try to compare this character of S1 with the remaining characters of S2. Or what will happen? I'll try to do, well, we will go on the right hand side, that I'll move forward in this. I'll keep the current character of second string and compare it with the next character of S1. And similar fashion, I'll keep on comparing this character with the remaining characters of S2. Okay, now consider the case when this keeps on happening. You got A, in this ABC example, you got A, which is common, then you have B. B isn't matching, you take B and then you take C. You take BC from here, you take C here, then you take C here and C here, it matches, then you move forward. You go to the case where you have reached the end of S1 and you have reached the end of S2 also. So for that case, from that point onward, will there be any subsequence or any character which will be contributing to your answer? You have already covered both the substrings completely. And how do we notify that? We will notify that str1.size, or j is double equal to str2.size. In that case, what we'll do is we'll simply return 0, that there won't be any character because the string has been exhausted. So it won't be contributing anything to the answers. So we have the two cases, we have considered these, we have returned. Now what should we be returning? Whenever we find this, we will be returning that, okay, this is going to contribute to our answer, and we will move forward in both the substrings, and this will be returning. Now the point is, should we be returning both of these? What does this return us? This provides the length of the common subsequence in the case where we were not comparing. Let's consider this. This is the left hand side. So this provides an answer where we were not considering the current character of S1 and trying to compare it with the remaining characters of S2. So it will give us the longest subsequence of that particular substring, and it will give the longest subsequence of the other substring. But what do we want? We want the max out of these. Whatever is the max, I need that as an answer. So if I run this case, it will provide us the answer. But okay, it's saying line number 11 is there is some fault there, or j is equals to str.size and member function and find LCS expected before this. Have I missed it? Yeah, I missed comma here. I have to put it here also. So yeah. So you see, here we are just comparing and we are trying to find out the answer. You see, we had these two substrings, and if I try to submit here right now, it won't pass all the cases. It should give us TLE. Yeah. Now are we getting TLE? TLE is time limit exceeded. That means here we are recursively comparing each and every case, and doesn't matter whether we have encountered that case before or not, we again compare it each time we get across it. So what we are doing is essentially this special case, this case, this one, LAXY AYZ and the AXY AYZ. We are comparing this again and again, even though we knew the answer at the first time we compared it, but still the next time we encountered it, we are again breaking it down further and finding out the answer. We don't want to do that because that could save a lot of time for us. So what we do is we simply create a grid. So a grid in C++ is created via this vector of vector. Let's call it DP, or let's call it grid for right now. Now in this grid, what will be the length of this grid? It will be n+1. Why would it be n+1? Because in this grid, we want to consider all the cases till the row and the column of these grid essentially mean till what point have I covered the row means till what point have I covered S1, and the column means till what point have I covered S2 string. So I comma j would mean the character string of S1, substring of S1 from 0 till I, and substring of S2 from 0 till j. So it will be n+1 because at the end, 0 to end, that is when we have come. The last would be, let's consider this example, custom input ABC ABC. Now if I keep the grid of 4 cross 4, when we are at 4th index after C, that means we have considered this entire ABC, and when we would be at the last of the grid on the last column, that means we had considered the entire AED. So that's why we are going to keep it as this, and then we have to initialize it to some value. So what should be the value that we initialize it with? Let's keep it -1. Now what -1 would signify is that we haven't come across this substring yet. Whenever we come across a substring, we'll store that answer in that specific position. So here, whenever we come across this substring, whenever we come across this case, that DP of either the I is at the end of the string 1 or j is at the end of the string 2, what we do is we simply have j, whatever is the current substring that are being considered, we just store that answer into this and we return this thing. We return DP of I comma j. So whenever this happens, that both the strings are equal, what will we do? We'll just compare DP is this. So we know whenever this substring comes up, we have the answer with us and we return that. And we will be returning that. Similarly here also, and we will be returning this. Now, this covers the case when we know that whatever answer we were getting, we have stored it. Now comes the most crucial part. What if I reached at a substring which is from, for S1, which is from 0 to I, and for S2 it's from 0 to j. This is what is meant by DP of I comma j. If this is a substring and we have the answer to it, then that means it will definitely be not -1. Why? Because it was assigned -1 at the start, and whenever we come across a substring of that particular length, we assign it to some other value which is not -1. -1 doesn't make sense. You can't have a substring or a character matching and say the -1 characters are matching in both these subsequences. What does that mean? That doesn't mean anything. That's an absurd statement. Could and instead of -1, it can be any negative value. If we keep it at 2, then that will be a problem. If we keep it at 0, that will also be a problem, because that would mean that we have compared it and the answer for this substring from 0 to I of S1 and 0 to j of S2 is 0, and that is not the case. That's why we have taken some negative value. And whenever this happens, that it's not -1, what we will do is we'll simply return the already stored answer instead of calculating the new answer. So let's just submit this. And this is the recursive approach and this grid essentially. Okay, now there is a problem. This grid is what we call as DP. DP stands for dynamic programming. We pass it DP here, and then we have this DP here also, and we pass the reference so that vector is not created every time the function is called. We don't create this vector again and again. We pass the reference to the same vector, because creating a vector can also take a lot of space memory wise as well as time wise also. So this is the subsequence problem, and it's expected. There are certain time cases which are still falling. The reason behind this is whenever we have this kind of problem where we are using recursion, so what happens in recursion is the compiler, whenever the compiler will be comparing this case, considering this case, it will go to the top. Now the values of I and j have been updated. It does all these calculations, and when it comes back, when it gets a return statement in that iteration, in that context, it returns back. Now it has to maintain the context of this previous iteration. So that takes a toll on the compiler's memory as well as time. So specifically memory, because compiler has to maintain the context at this point also now. It has to forget about the previous one, next one, and come back to the previous context. And whatever values of I and j were there, it has to regain those values. That's why it takes some toll on memory, and it gives you a TLE, because there is a lot of memory being utilized, and every time this context switch is there, it's utilizing some time also. So what is the other approach to this? The other approach to this is pretty much simpler. What we do is, instead of creating a recursive function, what we do is we just create a 2D DP, and right now you see whenever we are going to I comma j, DP of I comma j, it means substring from I to j. When we add this means substring from j to I. So utilizing the same concept, what we do is, instead of calling it recursively, first it has been initialized as -1. So what we try to do is excuse me excuse me yeah so what we try to do is, instead of initializing at -1, let's initialize it at 0. Now what the 0 means, because right now we were searching whether we have a current substring and we have the answer to it or not. But right now what we are going to do is, we'll start from the basics. We'll start from the start itself. So let's keep it -1. Let's change it later on when you understand the problem. I is equals to 1 and I should be less than what? The length of the string. I should less than I plus plus. And then we have this. And then for each character of I, we are going to iterate the entire grid. And j and plus. So now if you consider this, it should be opposite, first and j. You remember when I told you that this grid is when a dp of I comma j, what that means is first string considered from 0 to I, and second string considered from 0 to j, right? So we are going to utilize that same concept here, and instead of going recursively, what we'll do is, whenever we know that let's consider here, let me create a 2D DP. I'll have some lines created, and this, and one more line here, and then we have a line here, copy pasted here, pasted here. So let's consider this A, then we have B, then we have C, then we have D, and for this we have A, and we have let's consider the small example, ABC and AC. We have ABC. Let's remove this D. This D is not there, so this is removed. We have A, and we have just C. And okay, so the problem here is, it should be like this, and this should signify null character, empty space. We have not considered S1 at all. right? So let me copy paste it. Instead of this, let me just write this down. Yeah, under this we just need to move it here, and this is an empty string. So what we will doing is, when we are considering this, so when we are at this index, what this would mean to us is that this value is going to be 0 because there is no character of s1 or s2. When we are at this place, this would mean that we have 0 character from s1 and we are considering just the first character of s2. Can there be a common substring? No. Now when we don't have any substring in s1, it's always going to be 0. And similarly, when we don't have any string from s2, it's always going to be 0. It's going to be 0. So this is what that 0 signifies. So that's why we have the length also as +1. Now when we come to this index, we know at this point we are considering the first of s1 and the first of s2 also. So what does this mean? This means that s1, whatever substring we had in s1, we are considering the string from 0 to a, that is only 1. And s2 also 0 to a, that is only 1. So s1 and s2 at this point, when we are at this index, is a and a. Are they common? Yeah. Then that means we have an answer that a would be contributing to our answer. So that means whenever we are at any I comma j, that would signify the longest common subsequence till that part. And when we move forward, we don't have to compare and find out the subsequence in the entire grid. When we are at this, for example, when we are at this place, what we need to do is, if the characters are equal, b and c are equal, no, they are not equal, then that means we'll consider b and try to map it with the remaining characters of c. And how do we do that? We remain at b, we'll remain at this column, and we'll move further down in c. Can we move further down? No, we can't. That means this is where we stop. And similarly, what was the other case? Other case was, we are at c, we are comparing b and c. Now c is not equal to b, but c can be equal to some other character in string 1 after b. Is it? So we compare c. So we remain at c, and in the other string, we move 1 ahead. So we remain at c by remaining at this row. And in the other string, we have moved to the next column. So this row, this column, is c equal at this point when we are at this index? Yeah, it is equal. So whenever we get an equal, so at this point, what we'll do, since it is equal, what should we do at this point? Now you know that at this point C and C have mapped. So what will you do? You'll check, okay, C has been mapped. That means the characters before this. Now consider this smaller picture. C has been mapped, so we have the smaller picture. Let's consider this. So after C, we have these many characters. Now this is what we have in picture. So when we have that in picture, when we are considering just this much, we consider just this much after matching C. So the previous index would be there, because we want to find when the answer when S1 was AB and S2 was A. And where will we find that answer? We'll find that answer here. So whatever is here plus 1, because here we have mapped the value, will be our answer for the entire substrings. That is what we will be doing here. So whenever we get, if S1 str1 of I is double equal to str of 2 of j, at this point the answer would be dp of I comma j would be equal to dp of I minus 1, that this plus 1. Else, now when this was not the case, when b and a were not equal, we moved this in this direction and we moved in this direction. So what should we do? Just to clarify, when we were moving forward, when we moved here, what were we trying to do? Let's consider this in this format. So this is how we were approaching the problem in iterative format. But when we are not approaching the problem in an iterative format, what we will be doing is, let's here. So let's consider this case when we were at B and A, we were here. We know that B and A are not mapping. So at this point, if we move further ahead, like we did in a recursive approach, we go ahead, we started considering the next characters. If we do that, we don't know the answer for the next characters. So moving forward, we won't give us any good. But what will give us the good is if we move back. We have B and A, and we move one step back from here. That we consider A only for this string and nothing from this string. That will signify that B was not considered and A was considered. That means we are moving way ahead from here. Not instead of coming down, we are moving ahead from here. Every time we go, we move ahead. So what that means is, anyways, so what that mean is when we are at B, we go one step back. So when this doesn't happen, what we do is dp of I comma j is equal to max of dp of I minus 1 comma j and dp of, or it will be equal to I comma j minus 1. And when this is done, we'll be returning the dp of the entire, when the entire substring has been considered, whatever is the answer, that should be our answer. Now the problem here, yeah, we are returning -1. Okay, have I written? Okay, this is wrong. Let me correct this. And yeah, the answer is, so as I told you earlier, when initial column and initial row should be 0, because that signifies that when either of the string is empty, the answer is always going to be 0. So that signifies that. And here, instead of moving forward, we are just moving back. We are checking in the back, do we have an answer for the smaller version of this problem? If we have, we utilize that answer instead of moving forward. So when I submit this, it will pass all the test cases. It should, let's see. Oh, okay. There has been some problem, it seems. It hasn't passed all the test cases. And then we go to J. And then we see if str of I, yeah. So this is the problem. Now if you consider, when we see that both the characters are equal, so I is from 1, but the strings that we should be comparing is j minus 1. Why? Because when we are at this point, we have just, although I, let me just delete this and write it down. When we are at this point, I is equal to 1, but we are still considering the first character of S1. So that means this should be -1. You have one request queued already. Are you sure? You okay? Now let's see, it should pass all the cases. Yeah, you see, it has passed all the cases. Yeah, so since we opened this problem, this index, it has not given us any answer, but cool. Yeah, so this is how we solve the problem. I hope you like the video and how I approach the problem. Thank you so much.